Now we're going to solve that same problem, x double prime plus 4x prime minus 21x equals u3 of t, x of 0 equals 1, x prime of 0 equals 0. We're going to solve the same problem using chapter 4. So remember, in chapter 4 you just solve the homogeneous problem first, but actually the way we're going to solve this is we're going to solve x double prime, a terrible double prime, plus 4x prime minus 21x equals 0, x of 0 equals 1, x prime of 0 equals 0, for t between 0 and strictly less than 3, although, well, I guess you could say we'll go up to 3 to get our answer for our initial conditions. So we're going to solve that problem first, then we're going to come back and solve x double prime plus 4x prime minus 21x equals 1 with x of 3 equal, I don't know what it's going to be, I'm just going to call it x3, and x prime of 3 being xp3, since I don't know what it is yet, and I'll solve that, and that will be for t greater than or equal to 3. So that's what I'm going to do. Okay, so we solve the homogeneous problem first. So here we're going to have our r squared plus 4r minus 21 equals 0. And so there's our characteristic equation. We've done this already. We know this factors into, whoops, or maybe we don't know it factors into, r plus 7 times r minus 3 equals 0. So we have r equals negative 7 and 3 for our two possibilities. So at this point what we know is x of t is equal to c1 e to the minus 7t plus c2 e. I should look at my notes to make, oh, okay, sorry. I'm going to do the 3 first and then the minus 7t next. That's the way I did it in my notes. So there's the solution to the homogeneous problem, but actually this is our solution all the way up to 3. And so now I know that x of 0 equals c1 plus c2, but that equals 1, and x prime of 0 is equal to 3c1 plus minus 7c2, and that equals 0. And so I can find the c2s. I'm going to multiply through by 7, I guess. Multiply everything by 7, and so what I get is, and add those two equations together, I get 10c1 is equal to 7, and so c1 equals 7/10. But we knew that because we had that answer before, and then that would mean c2 is equal to 3/10. Alright, so at this point I have that x of t is equal to 7 over 10 e to the 3t plus 3 over 10 e to the minus 7t when we have 0 less than or equal to t less than or equal to 3. No, that was not my left thumb. Okay, so I'm wrong. I don't know what causes that. And so there's the first part of our solution. It matches what we had before. And now I can check x of 3. And if I put that in there, I get 7 over 10 e to the 9 plus 3 over 10 e to the minus 21. And x prime of 3, well, all that happens when I take the derivative is I bring a 3 down, multiply it by the 7/10, bring a negative 7 down, multiply it by the 3/10, and so I end up with 21 over 10 e to the 9 minus 21 over 10 e to the negative 21. So those are my initial conditions for the next problem. Well, I already know that the answer to the homogeneous problem, xh of t, is my 7 over 10, oops, sorry, not 7 over 10, we don't know the constants yet, c1 e to the 3t plus c2 e to the negative 7t. So we know that. Now we need our particular solution. And what I'm going to guess is, I suppose since the right-hand side is 1, okay, so, well, let's get up there. Remember that the right-hand side is 1 here. I'll guess that it's ax squared plus bx plus c, and I'll plug that in, so we need an x double prime. Well, the second derivative of this is just 2a, so I'll get 2a plus 4 times, and now I need x prime. Oh, sorry. I'm saying x prime, which is the correct thing, but I accidentally put x's in there instead of t's. So the second derivative is still 2a. First derivative is 2at plus b. And then, of course, the last thing, the minus 21 times x. Well, if the particular solution is this, I get at squared plus bt plus c. And that has to equal 1. So I plugged this particular solution in a differential equation, and I need to get 1 on that side. Well, notice, you know, the only t squared term is right there, so a has to be 0. But if a is 0, then that's 0. And so a was 0. But here's the t term. There are no t terms over here, so b has to be 0. Okay, so that's just gone, and 2a was gone, b was gone, and so we get that minus 21 times c has to equal 1, and so c equals minus 1 over 21. So we get our particular solution, xp is just, xp of t is just equal to the constant function minus 1 over 21. And so our general solution then, x of t is equal to our c1 e to the 3t plus c2 e to the minus 7t minus 1 over 21. And this is for when t is greater than or equal to 3. And so, if you can remember back to the previous solution, yeah, this is actually starting to look a bit like the previous solution because we had that minus 1 over 21 term in there. Okay, so I think I'll go to a new page to work on these constants, which is just going to be a little bit nasty. Okay, so I'll make a new page. Again, we have our x of t is equal to that c1 e to the 3t plus c2 e to the negative 7t minus 1 over 21. And then, well, x of 3, which is equal to c1e to the 9 plus c2e to the negative 21 minus 1 over 21. Well, that is equal to, and well, I got to come back and find that. X of 3, here we go. There's x of 3 is the 7/10 e to the 9 and 3/10 e to the negative 21. So we have 7 over 10 e to the 9 plus 3 over 10 e to the negative 21. So that looks like, oh wow, you know, so we get 7/10 and 3/10. Well, no, because there's this minus 21 in there. And what I'm going to do is I'm going to add it to this other side, so plus 1 over 21. So there are our first equation with two unknowns. And then we have x prime of 3. And x prime of 3 is going to be 3 c1e to the 9 minus 21 c2 e to the minus 21. Oh, yeah, I messed that up. That's a 7. So minus 7. And that is equal to, well, and again, we've got to go back and look here at x prime of 3, and that was right there. 21 over 10 e to the 9 and minus 21 over 10 e to the minus 21. So 21 over 10 e to the 9 and minus 21 over 10 e to the minus 21. Okay, so now we need to solve those two equations, two unknowns. Doesn't look like a whole lot of fun doing that. You know, it would be, I suppose, very tempting to, you know, pick C1 here based on this 21 over 10 because that's an E9. But actually it doesn't quite work that way. So you know, to solve these simultaneous equations, it is a pain in the butt. But you know, along those lines, what I can do, let's see, I'm just kind of looking back at my notes at what I did. I think in that case, yeah, it is still kind of nice that if I multiply through the top by 7, the top as in this x3, if I multiply everything by 7 and add, I do get, you know, so there will be 7 times that, 7 times that, but remember it's 7 times all this stuff over here. But when I do that, I do on this side just get 10 c1 e to the 9 because these two will cancel when I add everything together. But on this side, on the right side, well, okay, so I multiplied by 7. So I will have a 7 over 21 out here. So when I add that, that definitely, so 7 over 21, or 1/3. And then inside though, now notice when I do multiply this 3 here by 7, I'll get a 21. Here's a minus 21. So actually those do cancel, and what I have is 7 times 7 is 49, plus 21 here. 49, 21 is 70, and so I'll get a plus 70 over 10, or no, sorry, 70 over 100. Well, 70 over 10, because I've still got the 10 over there. So 70 over 10, or 7, e to the 9th. Okay, so that means that C1 is equal to, well, I have 1 over 30 from dividing this first term by 10, but I also have to divide it by e to the 9, so e to the negative 9. And then plus, and I'll get 7/10 for the second term, because I've got 7 divided by 10, so 7 over 10, and e to the 9 divided by e to the 9 is just 7 over 10. So there's C1, but now if that's C1, then what I know is that C2, e to the negative 21, so now I'm just going back to the original setup here, this x of 3. I'm just using that equation, the original one, C1 e to the 9 plus C2 e to the negative 21. So that is equal to, whoops, well, the right-hand side I had was 7/10 e to the 9 plus 3/10 e to the negative 21 plus 1 over 21. And now I need to subtract off my C1 e to the 9, and so I'll have minus, and C1 e to the 9, so I'll have a 1 over 30 where the two exponentials cancel out, and then I'll also have a minus 7 over 10 e to the let's see, what is it, 7 over 10, I lost my place here. Let's see, so here's the C1. I've got 7 over 10 e to the 9th that I had to bring over. Okay, now that's nice in that, oh, that cancels with that. And so C2 is equal to, I'll have to multiply through everything by e to the 21, so I will get a 3/10 because of that term, and then 1 over 21 minus 1 over 30, what the heck is that? Well, make everything actually over 210, and so that's a 10 over 210, that's a 7, so I get 3 over 210, or 1/70th, so plus 1 over 70 e to the 21. And that is my C2. And so what that says, cut that, when I put that together, is that x of t is equal to 7 over 10 e to the 3t plus 3 over 10 e to the negative 7t. That was the homogeneous, or well, let's see, that's the C1 part there. So you see I've got the 7 over 10 in that part, and then so there's the 7 over 10 times e to the 3t. And then I have my 3, so that took care of that part of C1. Here's 3 over 10 C2, so I took care of that times the e to the negative 7t. And then I need to take care of the 1 over 30, so that's plus 1 over 30, and that's e to the negative 9 and e to the 3t, so e to the 3t minus 9. Get that part, and so that takes care of that one. And then finally I have the plus 1 over 70 e to the minus 7t plus 21. So I have that. But then we had our particular solution. So remember, our particular solution was the minus 1 over 21, so I did the C1, C2, and then minus 1 over 21. So minus 1 over 21. And t, and this is for t greater than or equal to 3. So overall, what we found was the same thing we found from using the Laplace transform, is that we have the 7 over 10 e to the 3t plus 3 over 10 e to the minus 7t, 0 less than or equal to t less, and we'll use a strict less than 3 now. And then we have that same thing here. Okay, so that same part, but then we have that extra stuff added on. So again, we have the 7 over 10 e to the 3t plus 3 over 10 e to the minus 7t minus 1 over 21. And then I think those were pluses, right? Yeah. And then plus 1 over 30 e to the, now if I factor out a 3 up here in that e to the 3t minus 9, I can write it just like we had in the Laplace transform, t minus 3, and then plus 1 over 70 e to the negative, and if I pull out the 7, I'll have a minus 7 and then a t minus 3 because I had a plus 21. And so that's t greater than or equal to 3, and that is the same answer we had from using the Laplace transform. So very long to do these problems. This took me over 23 minutes, but we get the same answer. So it's not that we can't solve some of these problems both ways, it's just how we have to use our techniques from each chapter to get them. So that was a long one.